Here in example 4, we have this brand new thing. This see how it says it's a function for sure, but we've got two parts to this function. This is known, I'm going to write this out, it's called a piecewise function. And the reason why it's called piecewise is because this full function right here, f of x, this function titled f, is pieces of two other functions. And specifically, it's, x squared, we know an x squared, that's going to be a parabola, and another x squared. So what this function f is made up of is two parabolas. It's one half of a parabola, specifically when I pick x values less than 1, and it's another part of a parabola when I pick x values greater than or equal to 1. So I'm going to take 2 seconds and just kind of show you this. It has nothing. Then we're going to go through and actually answer the questions, but I kind of want to show you how this works. So remember, function notation is basically saying, okay, f of x is going to equal negative 1/2 x squared plus 3, as long as if I wanted to graph this in my t-chart, I had to pick x values less than 1. So it could, granted I can't equal 1, but I'm going to start at 1, and when I draw it, I'm going to write an open circle because there's going to be a hole in the graph because I can't equal 1. But then numbers less than 1 would be 0, -1, -2, and so forth. Okay, and then what I would do is plug it in, get my y values, and that'd be graphing. I'm going to graph that part. And then on the next one, I would start at 2x squared plus 1. And in this t-chart, it tells me I can pick x values greater than or equal to 1. So I can equal 1. I can do it with a closed circle, and then anything larger, and go on. So if I wanted to graph the function f, that's what I would do. And we're going to get practice with this later, but I kind of wanted to bring this up right now, kind of introduce it just a little bit. And this whole function, instead of just equaling one equation, it's bits and pieces of two equations. And honestly, piecewise functions can be huge. You can take tons of graphs. Have you ever seen those graphs that look something like they'll go up like this, then flat, maybe down, and then have like a curve? Well, look at that. That's 1, 2, 3, 4 pieces together making one big graph. So imagine 4 things along that line. And you'd be graphing basically a line here to the left for any x value, let's say less than 1. You'd be graphing this line for x values between 1 and say 4. You'll be graphing this line for x values between 4 and say 6. And then you'll be graphing a parabola from 6 on. So I mean, that's what a piecewise function is. It just kind of blends a bunch of segments of other types of graphs together. Okay, well, let's go back up and actually answer the question. First of all, it wants us to find f of -1. Okay, so the x value we want to plug into our function is -1. The question is, which one do I plug it into? Do I plug it into both equations, or do I just plug it into one equation? And what tells me, what's going to help me answer that, is this last little part on both right there. Where does -1 fall? Is -1 less than 1, or is -1 greater than 1? Obviously -1 is less than 1, so I'm only going to plug it into the top equation. So it's going to be -1/2 times -1 squared plus 3. Okay, so -1/2 times a positive 1 plus 3. So 3 minus a half, or 6/2 minus 1/2, is a 5/2. So f of -1 is equal to 5/2. All right, the next part they want us to find is f of 0. Well, where does 0 fall? Is 0 less than 1? Or is 0 greater than or equal to 1? Definitely 0 is less than 1, so I'm only going to plug it into that top equation again. And when I do that, that's going to wipe all of that one out, that first part, because -1/2 times 0 squared is going away, and I get f of 0 to be 3. Okay. And last but not least, they want us to find f of 1. Well, where does 1 fall? Is 1 just less than 1, or is 1 greater than or equal to 1? It's greater than or equal to, so this is where I'm going to use the second part. So 2 times 1 squared plus 1. So 2 times 1 plus 1 equals 3. So f of 1 equals 3. So anytime you see a function that's broken down, so important to be able to analyze what we're going to eventually call a domain, is figure out where is this graph confined to. Well, it's going to be this parabola confined on that space. It's going to be this parabola confined on that. It's very, very important to pay attention to this back part. It's all about that back part. Okay? All right, let's look at example number 5. which is 16 in the book. So if y'all will grab your books out real quick, turn to page 96, just read through number 16 and we'll join right back here. Okay, example 5, or number 16 in the book, is all about interpreting a graph. So I just kind of wrote what the problem asked us to find in parts A through D. I didn't want to draw the graph because that would be kind of crazy. So hopefully all of you guys have your book and you're looking at your book. Otherwise, you might as well skip ahead to the next example because this could make no sense whatsoever. But the first part says, find the value of f of 7. Now remember, whatever's sitting inside of this parentheses is always an x value. Okay? So what that means is go over on the x-axis to 7 and then go up or down until you hit the graph. Because when you're finding f of 7, you know the x value, you're looking to find the y value. So it looks like by the time we go over to 7 and go until we hit the graph, it looks like it's going to equal 3. So there's the answer to that. Now on part B, it says we want to find the values of x that go with a height of 5. How they could word that if they wanted to is just say find f of x equals to 5. Because it's saying we need to now find this. Because remember, what comes out is always a y value. What we're looking for are x values. So just go over to 5 now on the y-axis, go up to 5, and then we're going to go right or left until we hit the graph. Well, obviously, when we go right, we're going to hit the graph twice. We're going to hit the graph once at x equals 4, and then we're going to hit it again at x equals 6. So what we have just found was the fact that f of 4 is equal to 6. F of 4 is equal to 5, and f of 6 is equal to 5, and that's what we just discovered. Okay. Next part, it says in part C, is we want to find the point on the x-axis at which the graph crosses it, aka find the x-intercept, and then we want to, what's the value of f of x at that point? Well, obviously, when you're on the x-axis, your function has a height of 0. So when you're finding your x-intercept, your function is equal to 0. And this is going to occur at x equals 2. So in other words, f of 2 is equal to 0. Because when I have an x value of 2, my y value, or my height, is 0. Okay, and lastly, on part D for this, it talks about finding the domain and range. We're going to go into a lot of detail here with this one right after example 6. But just to kind of get started, a domain is a way to list out all of your x values. So how can I list out all of those x values on that graph? Well, this is where we kind of brought in our interval notation that we did when we talked about linear inequalities. There's really no way to list out every single x value that's listed on that graph because you got to think about it. There's not just whole numbers. There's decimals, there's fractions. It's pretty much an infinite number of numbers on that graph. So how we're going to do it is we're going to use our interval notation. Remember how interval notation always has to go from my smallest value to my largest value. So let's look on that graph, and what's the smallest x value that we see? We'll go to the far left of the graph, and it looks like the first value it starts with is -1, and it has a closed circle there, so we can actually equal -1. Well, what's the largest x value that we see there? Well, the far right that graph goes to is an x value of 9. So here's the interval right here. All the x values are found somewhere between -1 and 9. Now the range refers to the y values. And the y values, if we want to list all those out, again, we want to always go from smallest to largest. With an x-axis, it's left to right. Now for small to large on the y-axis, we're going to go down to up. So here it's left to right. With the range, we need to go down to up. So what's the lowest, the smallest, the lowest the graph gets to, which is the smallest y value? It looks like that's going to happen at -2, and it crosses through. And then the highest y value we're going to get to, it looks like that's up at 6. And again, it goes through that, so we're going to put a bracket. So there's the domain and range, and we're going to get right back to this whole concept in just 1 second. But first, let's just look at example 6. We want to find the value of c that's going to cause the point 2, 4 to be on the graph. Okay. Just remember the point 2, that's an x value. 4, that's a y value. And we're up here in function notation. Remember, all of that right there is a fancy way to notate y. So I could have written that equation as y is equal to x square roots of 9 minus x squared plus c. That's the exact same thing. Because remember, function notation, if we start on here in this form, we take away the y and then we put in the function notation, or vice versa. Take it away and put y back in. Okay, so to answer this question, then I know what y is. Y is 4, x is 2, so 9 minus 2 squared, and the only thing left in here is a c, which is what they're asking us to find. So 4 is equal to 2 square roots of 9 minus 4 is 5 plus c. So this right here is just a number. Let's move it over so we can get 4 minus 2 square roots of 5 is equal to c. And that's what c is. I could plug this in my calculator, but truthfully we just found what it equals. And the whole goal with this one was just to get practice of realizing that f of x, all of that, is the same thing as your y value. Okay, and like I said before, let's get back into the idea of what domain and range is all about. The domain is determined to represent all the x values. We call these the input values. It's always those values that are going to be in that parentheses that we're going to plug into our equation. And then all the y values are the range values. It's what's coming out of your equation. It's after you plugged in your input value, it's all these output values. And these are known as the dependent values. The values of your range depend on what you plugged in, the domain values. Okay? And we have possible options here. They're going to ask you to find the domain, and in one case you can look at the graph and do what we did before, like there in example 16 in the book. When we want to find the domain and range of a graph, you just look how far left and right that graph's going and how far down and up that graph's going. But what if you don't have a graph? What if you have an equation? And that's what this next part is in order to be able to find the domain of an equation, let's first of all look. If the equation is a fraction, it's rational, then what you're going to do, meaning it specifically has a variable in the denominator. That's all about what a rational equation is all about. It's a variable in the denominator. Then what you're going to do is figure out what value of x is going to make that bottom go to 0. Okay? Second thing that you could possibly encounter is if your equation has a radical. So if it's rational, we want to figure out what makes the bottom go to 0. If it's a radical, we want to find the values that make everything under the radical. We want to make sure it stays positive. Okay? And then if your equation doesn't have either a variable in the denominator or it doesn't have a variable under radical, then you don't have to worry about it. The domain in this case, you would list it off in interval notation as just saying all real numbers. You know, we can do like that R with a double bar through it means all real numbers. It's shorthand for all real numbers. Or we can just say it's going to go for every x value from negative infinity to positive infinity, everywhere left to right. And we always use interval notation when we're given domain and range. Okay. Remember, if you can equal some values, you're going to use brackets. Otherwise, if you don't know if it's going off to infinity, we have to put parentheses. But let's get practice with this one.